Good morning, students. Today we are going to learn the derivation of ideal gas equation from gas laws and some problems and their solutions. The first question is derive ideal gas equation or write about equation of the state or combined gas law. So, I already discussed in the previous video various gas laws in detailed way. Now, we simply remember those gas laws in the form of a short lines. So, this is at constant temperature, the volume of a given fixed amount of gas inversely proportional to its pressure. Its mathematical expression is when T and M are constant, V inversely proportional to P. So, boils now at constant temperature and fixed amount of gas, the volume of the gas is inversely proportional to its pressure. It can be written as when T and M are constant, the V inversely proportional to P, that is the equation 1. Similarly, Charles' law, at constant pressure, the volume of given fixed amount of gas V directly proportional to its absolute temperature. At constant pressure, the volume of a given fixed amount of gas directly proportional to its absolute temperature. When P and M are constant, V directly proportional to T. It is also we have learnt already. This is equation 2. The third one is Avogadro's law. A constant temperature and pressure, at constant temperature and pressure, equal volume of all gases contain equal number of molecules or moles. At constant temperature and pressure and temperature are constant, you take equal volumes of two gases contain equal number of molecules or moles. So, the temperature when temperature and P pressure is constant, V directly proportional to N. If V is increased, the moles also increased at constant temperature and pressure. This is the equation 3. By combining these three equations, 1, 2, 3 from equations, we have V directly proportional to N, directly proportional to T, directly inversely proportional to P. So, the product Nt by P also directly proportional to V, or V directly proportional to Nt by P. So, proportionality, if you want to remove proportionality, you have to multiply with a constant R. V is equal to R Nt by P. R is called universal gas constant. Why R is universal gas constant? Because it is the same value for all gases. R value is same for all gases. So, it is called universal gas constant. Its value simply you can write 0.0821 liter atmosphere per degree Kelvin mole, liter atmosphere per Kelvin mole. So, R value 0.0821 liter atmosphere per Kelvin mole. So, it is called ideal gas equation. PV is equal to nRT is called ideal gas equation. P is sent to the other side, PV is equal to nRT. This is called ideal gas equation or the equation of the state. Here R has several values. So, we have to see various values. If we ask P and V and T, these values are used. If we ask energy values, then you have to use energy. Suppose you want to calculate kinetic energy, 3 by 2 RT, Ek is equal to kinetic energy is 3 by 2 RT. This is some formula you will get. At that place, R value should be taken 8.314 joules or ergs into 10 to the power 7 ergs. 8.314 10 to the power 7 ergs Kelvin mole R value should be substituted. So, here there are several values you see. R value 8.314 pascals meter cube Kelvin inverse mole inverse. Pascals is pressure. This is a meter cube is a volume. 8.314 into 10 to the power minus 2 bars liter. Bar is also pressure, units of pressure, liter is volume units, Kelvin inverse and mole inverse, or by Kelvin mole, or you can write 0.0821 liter atmosphere per Kelvin mole, or liter atmosphere Kelvin inverse mole inverse 0.0821. So, in this way, so you can take R values accordingly to calculate P, V or T in the above equation. P V is equal to nRT, which is called ideal gas equation or equation of the state. So, now let us see. So, if the temperature, volume, pressure and fixed amount of gas vary from T1, V1 and P1 to T2. T1 is converted into T2, T1 is changed into T2, V1 is changed into V2, and then P1 will be changed to P2. So, at the first stage T1, V1, P1 are the variables for the same gas. They are changed to T2, V2, P2. Then the equation above equation P V is equal to nRT will be, you can write like this. In the first stage P1 V1 by T1 is equal to nR. N is moles, R is constant. N moles are constant, R is also constant. So, P1 V1 by T1 is equal to constant. Similarly, in second stage the pressure is P2, P2 volume V2 and T2. P2 V2 by T2 is equal to also for the same gas the moles are same, and our gas constant is also same. So, you can equalize these two, P1 V1 by T1 is equal to P2 V2 by T2. This equation is also known as combined gas law. P1 V1 by T1 is equal to P2 V2 by T2. This equation is known as combined gas law. By all three laws are combined to get this one. So, this equation is named as P combined gas law. So, relation between the density and the molecular weight or molar mass of the gas, let us see. So, here find the relation, he may ask like this, find the relation between density and molar mass from the gas equation. So, P is equal to nRT is the ideal gas equation. P by RT, RT is brought to this side and V is brought this side, N by V. P by RT is equal to N by V. Replacing moles N by N as N is equal to molecular weight by weight by molecular mass or molecular weight. So, W by M or M by capital M you can write. So, M by capital M, M by N instead of N, M by capital M, and V is also there. So, this part is taken to left side, M by M V, and P is equal to P by RT, P by pressure or T, or gas constant, T is absolute temperature. Now, M by V is equal to D, M by V is equal to D, D by M, this is D by M is equal to P by RT, D by M is equal to P by RT. If you want molecular mass M, then what happens? dRT by P. As multiplied, P is equal to dRT, M is equal to dRT by P. So, you can find the molecular weight if you know the density, gas constant, absolute temperature and pressure. So, M is equal to dRT is a good equation to find the molecular weight or molecular mass if you know the density of the gas. Similarly, if you find density, temperature and P1 pressure at first one stage, in second stage the density is changed to D2 and temperature changed to T2 and P1 is changed to P2. Both are the M by R are constant, M by molecular weight is constant, R is constant. So, in both you can equalize in both the states, so that you will get D1 T1 by P1 is equal to D2 T2 by P2, D1 T1 by P1 is equal to D2 T2 by P2. If you know density, temperature, absolute temperature P1 in one stage, you can find the density when you know T2 and P2, temperature and pressure. So, this is also useful to know the or to calculate the density when you know the initial density at a particular temperature and pressure, you can find the density at other temperature and pressure. So, this is the problem you see at 25 degree centigrade 760 mm of Hg pressure, a gas occupies 600 ml. Find the pressure of the 640 ml of gas at 10 degree centigrade. 10 degree centigrade. So, in first stage what have we given? Temperature is given, pressure is given and volume is given. In second stage, volume is given and temperature is given. He is asking pressure. So, this is one question, and another one question is also there, and find the volume at STP also. There are two questions, two problems involved in this the given problem. So, first problem at 10 degree centigrade and 640 ml the pressure should be calculated. In second problem, you have to find out the volume at STP. Let us do how A and B, the two problems can be derived or solved. So, first state P1 is equal to 760, B1 is equal to 600 ml. Temperature should be absolute scale, he has given centigrade. So, 25 plus 273 gives 298 Kelvin. 298 Kelvin. In second stage, P2 you have to calculate, find the pressure. B2 is 640 ml, T2 is 10 plus 273, 283 Kelvin. So, you know the combined gas law, P1 V1 by T1 is equal to P2 V2 by T2. You want P2, P1 V1 by T1 into T2 by V2. So, 760 into 600 by 298, 760 into 600 by 298 into 283 by 640. After calculation, you will get 676.6 mm of pressure. This is final pressure in the first problem, the A problem. So, second problem, find the volume at STP. The first stage is common in both the cases, P1 760 mm, volume 600 ml and T1 298. But the final stage is changed, STP state. P2, what is STP? Standard temperature and pressure. Temperature is 0 degree centigrade or 273 Kelvin. So, again you want Kelvin, so T2 273 Kelvin. And 1 atmosphere pressure, 1 atmosphere is nothing but 760. This is you have to see if the P1 V1 T1 units should be similar to the P2 V2 T2. If not, you have to convert, you have to change, you have to transform in the same units, then only your problem will be correct. So, P2 is 760 ml, V2 is question mark, T2 is 273 Kelvin. So, again is the same formula, P1 combined state combined gas law, P1 V1 by T1 is equal to P2 V2 by T2. You want V2 now, V2 question mark, V2 P1 V1 by T1 into T2 by P2, 760 into 600 by 298 into 273 by 760. So, that 760 cancel out. So, that you will get after calculation 549.6 ml. So, generally let us recall the various equations so as to calculate various problems an ideal gas equation. So, these are the equation P V is equal to nRT, it is the equation of the state or ideal gas equation. Instead of n, you put W by m, weight by molecular weight or small m by capital M, RT, you will get P V is equal to W by m RT, P you send this V to the other side, W by V, RT by M, W by V is nothing but density, dRT by M you have already seen, M is equal to dRT by P, M molecular mass, dRT by P already you have derived. Similarly, this is combined gas law, P1 V1 by T1 is equal to P2 V2 by T2. If you know the P1 V1 T1 in one stage, you can find out the one term if you know the other two terms, or that is STP volume can also be calculated by this equation. Similarly, P1 by T1 is equal to P2 by D2 T2, already this one we have seen. So, it is simply inverted d1 t1 by p1. This is also inverted d2 t2 by p2. Either these are useful to calculate the density. If you know the density at particular temperature and pressure, you can calculate the density at STP or other temperature or pressure. STP means T2 you have to use 273 Kelvin, P2 760 pressure. Then D2 will be the STP density it will be. In this way several problems you can do, but you have to see the R values, proper R values in these. R values again, once again I am repeating 0.0821 liter atmosphere per mole, 82.1 milliliter atmosphere per mole. So, you have to see volume in milliliters and atmospheres and pressure is at atmospheres, then only this value you have to use. Volume is liters and atmospheres mole, the pressure is in atmospheres, then 0.0821 R value should be used. This is liter and millimeter, millimeter. Then 62.4 milliliter, millimeter, 66.24 10 to the 4. This is 4 here. It is not shown clearly. It's 8.314 10 to the power 7 ergs. Energy units if you want 10 to the power 7 ergs. This is also 7. 7 is not there. 8.314 and 10 to the power 7 ergs Kelvin mole. 8.314 joules Kelvin mole. 2 calories if you want to find out the calories, some energy units. These 3 are energy units. These 3 are normal units. So, for to energy, whenever the any energy equation has R values, so you can calculate in CGS this X R value you have to use. In MKS or SI unit system 8.314 joules you have to use. Sometimes you can use the calories, 2 calories per Kelvin mole. The exact value if you want 1.987. Instead of it is rounded off to calories, but actual value is 1.987 calories per Kelvin mole. So, R has only one value, but it seems several values in considering their units. So, this is the ideal gas equation. So, thank you very much. Subscribe for more information. Thank you.